We're now going to move into some related rate problems that make use of the Pythagorean theorem. Take a moment, read through problem number 7. I feel like to make any sort of sense out of this whatsoever, we need to draw a picture. So I'm going to put this in my part 1. I'm going to draw a rocket launching pad. That's going to be right over there. There's my rocket launching pad. I have a camera that is 3,000 feet away. This is not super exciting in my drawing, but whatever, I'm going to say that's a camera. And I know that this distance is always 3,000 feet. I have a rocket over here that's going up. And we'll get to some particular heights. I want to deal with my camera to rocket distance, find the rate that that's changing when the rocket's 4,000 feet above the launching pad. Well, I'm going to go draw in a hypotenuse over there, and I've got a right triangle happening here. I know that the base of my triangle is always 3,000 feet. The distance from the camera to the base of the pad is not changing. But I know that the height of the rocket is changing, and I know that the distance from the camera to the rocket is changing. So I want to make those some variables. How about I say this is A and this is C? The reason I chose those variables is because we have our Pythagorean theorem that says A squared plus B squared equals C squared, which is the formula I'm going to use in all the problems in this section. I really probably shouldn't have that B in there though, because this side of the triangle is not changing. It's always 3,000, so I'm going to fill in 3,000 over there. And I might as well clean this up. A squared equals 9 million. No, not A squared equals 9 million, sorry. A squared plus 9 million equals C squared. Next. The rocket rises vertically at a rate of 800 feet per second. What is that? Is that a dA dt or is that a dC dt? The rocket's rising, that's the rate of change of this side of the triangle. I know dA dt is going to equal 800 feet per second. See if you can go do part 2. Figure out what we're looking for in general and specifically. Find the rate that the camera to rocket distance is changing. That means find dC dt. When the rocket is 4,000 feet above the launching pad, so when A equals 4,000 feet. Well, here we go. Time to deal with the calculus. This over here is the formula that I want to find the derivative of. The derivative of A squared is 2A, but don't forget, after 2A, you got to multiply by what? We need a dA dt there. Plus, oh, this is nice, derivative of 9 million, 0. On the other side, the derivative of C squared will give you what? I hope you said 2C times dC dt. I'm going to plug in my rate that is constant, so I'm going to plug in my dA dt. I'm going to plug in 800 for that. I'm going to get 1,600A equals 2C dC dt. Part 4. I am about to run into a little bit of an issue here. I know that A is 4,000, but the problem is when I plug that in, I still have both a C and a dC dt in my answer, and that's not okay. Any ideas how I can find my C given A is 4,000? Any ideas what I can do with that? Well, let's see. For my specific instance, I know this is always 3,000. I know that at my specific instant, the height of the rocket is 4,000. I think we can just use Pythagorean theorem to find that C value. Actually, there's a shortcut with this. Normally we'd use Pythagorean theorem, but I think over here, this looks like a 3, 4, 5 right triangle, so I know that my C value is going to be 5,000. Okay, well, now I've got everything I need. I'm going to say 1,600 times 4,000 equals 2 times 5,000 dc dt. Go to the calculator, finish this off, and then put some units on the answer. Tell me what dc dt is. Let's see. I am thinking, whoops, hold on a minute. Yep, I am thinking 600, dc dt equals 640. Let's see, all the sides are measured in feet, so the units for C is feet, units for T, the time, is in seconds. That distance is changing at a rate of 640 feet per second. So all the problems in this section will make use of the Pythagorean theorem. We're going to take a look at 2 more in this video, and then 3 Pythagorean theorem ones in the next video. Take a moment, read problem number 8. So every single calculus book I've seen includes these problems where you have some ladder leaning against the wall of a house and sliding down. So let's see, here's the wall. Here's my floor. I have some ladder and it's sliding. As like this comes down, this is coming out, and all that good stuff. How often does this happen in the real world? Not so much, but it makes for a really nice related rates problem, so we're gonna see what we can do here. I'm gonna fill in some variables there, an A, B, and a C. For starters, one of these variables, as the ladder's sliding down, is not changing. Which variable is not changing? I think as the ladder slides down, the height over here is changing, the base over here is changing, but the length of the ladder, that's not changing. That is always 30. I'm going to fill that in as 30 feet. Okay, so we're going to go write out our Pythagorean theorem. Yeah, I've got a squared plus b squared equals c squared, but again, that c is always 30, so I'm going to go fill in that 30, which I'll then square. And I have a squared plus b squared equals 900. That's the formula I'm going to use. Now, the base is being pulled away at a rate of 3 feet per second. What is that? dA dt or dB dt? Here's my base. That's the thing that's changing, dB dt. Now, I need to figure out if this is going to be positive or negative, and basically the way to answer that question is, as this gets, pulled out, is this side of my triangle increasing or decreasing? I think that side is increasing. So I'm going to say this is positive 3 feet per second. Take a moment, set up your part 2. What are we looking for? In general and specifically. Might as well just continue down here. I want to find how fast the top is moving. That's dA dt. In particular, when the base is 8 feet from the wall, so when b equals 8 feet. You go do part 3. The video will pause, push continue when you're set. Derivative of a squared, 2a dA dt. Derivative of b squared, 2b dB dt. Derivative of 900, 0. Filling things in, I know dB dt is always 3, so I can fill that in. And I can say that 2a dA dt plus 6b equals 0. Part 4. I want to plug in my 8, but I also need to know the a value. Let me go and solve my right triangle first. I know that b is 8. I know that c is always 30 feet. I don't think there's any way around Pythagorean theorem here. So take a moment, use the Pythagorean theorem, And why don't we get an exact answer for a that has a root in it? I've got a squared plus h squared equals 30 squared. I've got a squared plus 64 equals 900. A squared equals 836. So a is going to equal the square root of 836. We can simplify, whatever. Let me just go. 2 times the square root of 836 dA dt plus 6 times 8 equals 0. Let's see, that's negative 48 on the other side. Looks like dA dt is going to equal negative 48 over 2 root 836, or negative 24 over root 836, or simplified or rationalized or whatever. Or I'm also okay if at this point you just go to the calculator and get a decimal, although we're going to have to follow the AP exam rules of accurate to at least 3 decimal places. Go to the calculator, and this should give you about negative 0.830. And I'm going to say that's feet per second. It's okay that it's negative because as the ladder is sliding down, you're decreasing this side of the triangle, so negative 0.830. Take a moment, finish making any notes that you need to from that problem. And then one more for this video. Go read number 9. I definitely need to start this problem by drawing a picture. So, let's see. Here's Ashland High School. And Superman is, I don't know, let's see. Let's say Superman is over here. And we'll give him a cape. That's kind of a cape, whatever. He's going in this direction. I don't actually know that he's going in this direction. He could be going in the other direction, but things will kind of work out. And let's see. I can make a right triangle out of this. There's the distance between Ashland High School and Superman. There's the height that Superman is off the ground. I'm going to fill in A, B, and C. My first question for you is, which of those sides is not changing as Superman is flying horizontally in that direction? Again, could be the other direction, it's not going to matter. But what side is not changing? I think that he's always 6 miles above the ground, so I think this height over here is 6 miles. Well, our Pythagorean theorem says a squared plus b squared equals c squared, or in this case, 6 squared plus b squared equals c squared. How fast is he flying when the distance between him and AHS is exactly 10 miles and this distance is increasing at the rate of 40 miles per hour? The distance between him and AHS is increasing at a rate of 40 miles per hour. So what is that? Is that dB dt or dH dt? The direct distance between him and AHS, that's dC dt. I know that dC dt equals 40 miles per hour. What am I looking for? I want to find how fast he is flying. Well, that's basically the rate of change of this distance, the horizontal distance. Speed, velocity, whatever, will always be measured relative to the ground rather than on a slant to like the object we're dealing with over here. So I want to find the rate of change of this distance over here. I want to find dB dt. In particular, when the direct distance between Superman and the high school is 10 miles. So when C equals 10 miles. I think that's all that I want to do. I want to see if you can finish this off and it will work out nicely. No roots, no any of that stuff. See if you can figure out what your dB dt is, and submit that to Edpuzzle. So derivative of 6 squared, derivative of 36 is just 0, plus 2b dB dt equals 2c dc dt. I know dc dt is always 40, so I'll fill that in. I've got 2b dB dt equals 80c. Part 4, I'll deal with my specific instant. Well, for this triangle over here, a is 6, b is what I'm looking for. I know that at my particular instant, c is 10. We can use Pythagorean theorem, or actually, this is just a multiple of a 3, 4, 5 right triangle, so I'm going to cheat and just say that's 8. But if you don't see that, go use Pythagorean theorem. You'll still get 8 over there. 2 times 8 dB dt equals 80 times 10. 16 dB dt equals 800. dB dt is going to equal 800 over 16, which should, let's see, I don't know, 800 divided by 16, that should give us 50 miles per hour. What's Superman's speed? 50 miles per hour.